Hey, let's cover the review for exam one. This is covering linear functions, exponential functions, and percentages. So the first one is a function d of h gives the number of miles Billy has driven in his car from his house h hours after leaving his house. And it says to interpret d of 4 equals 160. So I just want you to interpret what's happening here. If d of h, and they're telling us the definitions of what each of these things are, is the number of miles. So the number, not a hashtag, number of miles. And H is the hours after leaving his house. So hours after leaving. I'm just going to put home. All right. So the 4 is representing the H. The 160 is representing the D of H. All right. So 4 hours after leaving home, Billy drove 160 miles. Or Billy drove 160 miles 4 hours after leaving home. Either way, write the sentence as you would. I'm just going to write 4 hours after leaving home. Billy had driven, because it's been past tense. I'm not going to grade that on you. Had driven 160 miles. All right. Be careful, because if I put in there that if the term where the 4 is, if it has to do with the number of years after a time period, I'm not looking for 4 hours after 2025. I'm looking for the year. So if I give you a 4 and it's representing 4 years past 2025, you should say in 2029. Okay. Don't put it as this one. I couldn't do that way because there's no answer for that. All right, so let's go to the next one. The function g of t is given in the table below. Ooh, let's get rid of that light. Ooh, there we go. We've got t, which is the input variable, and then g of t is the output. So if you plug in a 0, you get a 12. It says evaluate g of 1. And what I asked myself on this is, when t is 1, because t is 1 here, this is representing g of t. So when t is 1, what is the function? What is g of t? That's the question I ask myself every time. So t is 1. T is 1 right here. G of t is 24. So 24. The next one is g of 6. Pause it. You should have already tried these anyway, so I don't know when you say pause the video. So when t is 6, what is the function? T is 6 here. The function is 3. Done. When determine t when g of t is 24. This means when the function is 24, what is t? Well, here the function is 24, t is 1. So you could write t is equal to 1, or you could write g of 1 is equal to 24. They are both correct. I would take either one. The next, just don't write 1. That's wrong, because you're letting me know that t is 1. The next one is 24 for the function is here. So you could write t is equal to 3, or you could write g of 3 is equal to 24. Either one, both acceptable. All right. The function f of x is represented below as a graph. And it says use f of x to answer the following question. Evaluate f of 0. All right. So this is x. This is our f of x, also our y, it's the same thing. So where x is 0, when x is 0, what's y? That's basically what we're asking on this. When x is 0, what is f of x? So when x is 0, it is the y-axis, and I just need to find the point on the graph, and it's right here. Well, f of x is -2. I ask myself the same question here. When x is 4, what is f of x? When x is 4, right here, find it on the graph. F of x is 2. Determine x. Now we're looking for what x is given f of x. So given, if you want to replace this with y, do that. Whatever makes sense to you to understand how to do this. But understand y is f of x. So when f of x is -3, right here, find it on the graph, right there. See where that is. What would the x be in that place value? It would be -1. If it helps you to see this a different way, like what is this point? Because you learned this way back when. What is this point? This point is -1, -3, right? That -1 is your answer because that's the x value. Or you could say f of -1 is equal to -3. I would accept either one of these answers, okay? Just don't write -1. The next one is determine x when f of x is 1. Well, f of x is 1 right here. Find it on the graph. What is your x place value? 3. So x is 3, or f of 3 is equal to 1. If you have any questions about this, if I'm going through here, please make sure and shoot me an email. Let me know if you need to meet up on Zoom. I am available on Monday to meet as well if you need to. Given the function k of t is equal to -8t plus 9. Well, again, this is representing the t. So what I'm going to do for this one is I'm going to come up here and do this. K of 3, and everywhere there's a t, I'm going to replace it with 3 since that's what they're doing here. So -8 times 3 plus 9 is 8. 8 times 3 is -24 plus 9. Get my notes here. Sure, I'm saying everything I want to. And then the signs are opposite, so you have to subtract and take the sign of the larger number, so it's -15. All right, B. Same exact thing. We're replacing 0 with t now, so k of 0 is equal to -8 times 0 plus 9. Anything times 0 is 0. So this is just 9. So k of 0 is 9. This should be k of 3 is -15. All right, last one, C. Determine t. So we're going to be solving on this one. Anytime we're solving, anytime we're looking at for t, we're solving. It's like looking for x. When k of t is -39. So here's k of t right here. All we're doing is substituting -39 because they're saying k of t is equal to -39. So I'm just going to substitute -39 in for k of t. And solving for t. So start by subtracting 9 from both sides. Signs are the same, so we add. Divide both sides by -8. Signs are the same, so it's positive. We're dividing. And 48 divided by 8 is 6. So t is equal to 6. You can either answer it if t is equal to 6 or k of 6 is equal to -39. Both are very acceptable answers. One is not necessarily better than the other. All right. Identify the rate of change and the initial value. Remember, the rate of change is the coefficient of the variable, is the coefficient of x in this case. Coefficient means it's the number in front of x. And it's not just 10. I have had students say that it's not, it's -10. So the rate of change is -10. And the initial value is your b, which is -9. Okay. Calculate the rate of change of the linear function that contains these points. I'm going to rewrite them real quick because I like to label mine. Always, always. And I'm going to give you your first formula you need for your exam. And that is the slope formula, or the rate of change formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Put this on your note card if you do not have it memorized. I do not expect you to have it memorized. x sub 1, y sub 1, x sub 2, y sub 2. All right. So m is equal to y sub 2, negative 14, minus y sub 1, 30, over x sub 2, 7, minus negative 15. The signs are the same, so we add them and keep the sign. So negative 44 over, this is a negative times a negative. This becomes a positive because they're right next to each other like this. So this becomes 7 plus 15. I'm not skipping steps here. I want to make sure everyone sees the same thing. I'm going to bring this up here. Negative 44 over 7 plus 15, 22. Once you divide, negative divided by positive is a negative. 44 divided by 22 is 2. So the rate of change is negative 2. Determine the rate of change and the initial value. The initial value is always your y-intercept. Okay. It's also the one, if it's a y-intercept, that means the x is always 0. So this is your y-intercept, which is your initial value. So the initial value, helps if I can spell, initial value is 14. Done with that part. Now let's do the rate of change. I need 2 of these points to do the rate of change. I'm just getting myself set up here. I'm going to use 0, 14, because who doesn't like 0? It's delightful as far as using it for calculations. I know a lot of you don't like negatives, so let's just stick with in the positives if you want to. It doesn't matter which number you choose, which point. I'm just going to just choose this one. 256. They're all going to give us the same answer. So if you chose a different number set, it's not an issue. You're going to get the same answer. All right, if you did it right. So rate of change is m equals y sub 2, same formula I already gave you, 56 minus 14 over 2 minus 0. 56 minus 14 is 42. And then 42 divided by 2 is 21. So 21. There's my answers. Next. Price of a gallon of gasoline is increasing by 3 cents per week. If the price is $3.10 per gallon today, what will it be in 10 weeks? Okay, so to do this, I don't tell you to write a linear function. Okay, you can, I do, but you could also just calculate it. It's your call. I prefer a linear function. So if I know the price based on weeks is price per gallon, and this is my weeks, I have an initial value of $3.10. Remember, I said to use this for your linear functions, especially with word problems. I know you have mx plus b in your wheelhouse. Use that if you prefer. This is just what I prefer with word problems because it makes more sense. Because the price is $3.10 and it is increasing. So I just have to add 3 cents per week. And 3 cents is represented like this. And week is W. So there's my linear function. All right. So now all I have to do is how much will it be in 10 weeks? And I just substitute weeks for 10 and I can find out. $3.40. All right. So the price, I have to answer with the sentence. The price will be, don't forget your dollar sign, $3.40 in 10 weeks. There's your answer. You can rent time on computers at the local copy center for an $8 setup charge and an additional 30 cents for every minute. That's a linear function if I've ever seen one. So f of x is equal to the initial value is $8. That's the initial price. And then they're adding another 30 cents for every minute. So maybe not using f of x. Let's use price per minute. That makes more sense. If you used f of x, I'm totally cool with that. You should know that by now. So price in total is the P of M, and M is the minute, and price in total based on minutes. So it's $8 plus 30 cents per minute. There's my linear function. And I define my variables. So if you use f of x, that's cool. You just need to define what the function is and what the variable is inside. So define both. B is how much will it cost to rent the computer for 15 minutes? Well, I just plug in 15 for minutes. $30 times 15 is 450, isn't it? 4.5. 8, 9, 10, 11, 12, 12.5. So to write the answer, it will cost, don't forget your dollar sign, $12.50. Do not forget to add that last zero. You should always go to the hundredths place for American money. So always put the zero. Even though I didn't have it here, it has to be represented in money. You will never see this. That's not American. That's un-American. To rent, sorry, I'm just a computer for 15 minutes. There you go. Next victim. Oh, these are fun. I like the validity ones. Great. Until about 1850, humans used so little crude oil that we can call the amount zero, at least in comparison to the amount used since that time. By 1960, humans had used a total, cumulative, of 600 billion cubic meters of oil. Create a linear model that describes world use since 1850. Discuss the validity of the model. So we're making a linear model here. We have to anyways. First of all, I see in 1850, time is always your x variable, your x value. If it's there, if it's time, time is your x, and it has zero for the amount used. 1960, there was 600 billion. So I'm going to put 600. That's all I'm going to use. Cubic meters of oil. So I'm going to write this out. To create a linear model. So that would be, starts off with zero, and it's increasing by what? Well, I have to find my rate of change. So x sub 1, y sub 1, x sub 2, y sub 2. I've got 600 minus 0 over 1960 minus 1850. All right. Well, that's 600 over 110, which is 5.45. Continue, continue, continue. So writing out the function. We'll just use f of x. And f of x is the world oil use. And x is the number of years since 1850. Well, they start off with 0. And then 5.45 x. You have to understand what your linear function means. Your linear function means that beginning in 1850, there was no oil use. And then every year since 1850, the world has used 5.45 billion cubic meters of oil. So, speaking to the validity of the model, how would the world have gone from 0 use of oil to 5.45 billion cubic meters of oil from 1850 to 1851. And then 1852, the same thing. We didn't have enough cars. We didn't have enough cars for this to happen. So validity, okay, do we have to describe we have to describe the world use oil. So describing the world use oil, the model shows, I know you're excited, from 1850, world oil use, that's what I described, world oil use has been increasing, because remember the plus sign is increasing, by 5.45 billion cubic meters per year. Since 1850. Validity. My second part. There would not be enough cars, or there were not enough cars in 1851 to be able to have used $5.45 billion cubic meters of oil. So not valid. Next one. The price of a particular model car is $15,000 today and rises with time in a constant rate of $800 per year. Okay, it's a linear function. So write an equation for the linear function and use it to answer the given question. Okay, so I'm going to write that first, and it's the price raises per year of, okay, I'm going to use X as years. This is price of car. And it starts off at $15,000, 2, 3, and it's going up by $800 per year. There's my A. Oops, sorry. There's my A. B, how much will a new car cost in 3.5 years? Price in 3.5 years would be 15,000 plus 800 times 3.5. 800 times 3.5 is 2,800 plus 15,000 is 17,800. So for B, how much will a new car cost in 3.5 years? A new car will cost, don't forget your dollar sign, $17,800. Now, notice I'm not putting 0.00. I can, but because there's no decimal, as far as there's not 0.5 or 0.8, I don't need to. $17,800 is legit as long as there's no change involved. So will cost $17,800 in 3.5 years. Okay. Briefly discuss whether a linear model is reasonable for the situation described. So what I did was I looked, okay, what does it look like in 10 years? In 10 years, a new car would be 23,000. In 20 years, a new car would be 31,000. It's easily possible. So at this point, what I did was I validated. In 10 years, a new car cost would be 23,000. In 20 years, a new car cost would be 31,000. And I also did 50 years because who knows? We may still be alive. 55,000. It's valid. I think it's valid. It might be a little on the low side, honestly, at this point. Because if you think about a car from 19, let's see, with 1950 to 2000, did it go up that much? Yeah, it did. So at this point, and this is just me writing, you write your own thing. I don't need you to write exactly what I do. It seems it could be feasible. Because I produced, I don't know how to write feasible. It could be valid. It could be feasible. It could be reasonable. Choose a word. It doesn't matter. Okay. What matters is that you let me know. Given the function, evaluate the following. All right, I'm going to hold off on this and do this no, I'm just going to do it all. Let's just be done. F of x is equal to 24.72 to the x. So we're just substituting -3 for the x. So A is f of -3 is 24, 0.72 to the -3. You can put it in your calculator just like that if you have anything but the TI-30XA. The XAs need to put your multiplication sign in here, okay? Otherwise, everyone else, 24 parentheses, 0.72 parentheses, caret, -3. And I'll write that down for you. 24 parentheses, 0.72 parentheses, caret, -3. If you're multiplying up here in the exponent, that's when you need to use the parentheses in the exponent. But that's going to give me an answer of 64.3. B. F of 0. 24, 0.72 to the 0. Anything to the 0 is 1. That's 24 times 1. All right, C is F of 2. 24, 0.72 squared. So F of 2 is 12.4. Because it's decaying. All right, the next one, I told you if you were in class that we are not going to do these. All right, identify the initial value. Remember, it is f of x is p1 plus or minus r to the x. Okay, and this is your next formula that you're going to need. The initial value is your p, so it's 170. This is 0.8 because it is less than 1. You might want to have that as well. If it's less than 1, it's decay. You might want that on your note card. If it's 1 or greater, it's growth. So you can just circle it. I'm fine with that. And then identify the growth or decay rate. So we're identifying the decay rate. And to do that, you have to use 1 minus r. You might want this too. For decay, it's 1 minus r is equal to what's in the parentheses. Okay, I gave you that in your original notes. I'm just going to solve for r. Divide both sides by -1 because there's a negative for the r, and r is equal to 0.2. You have to multiply this by 100 to make it a percent, which is 20%. So the decay rate is 20%. Next one, I know, identify the initial value, 110. This is growth because it's 1.3. And then the growth rate, you're going to take 1 plus r equal to what's in the parentheses and solve for r. Multiply it by 100 to get your percent. So the growth rate is 30%. Don't forget your percent sign. Write a function, because I'm not going to tell you exponential on the exam. I'm not that nice. Write a function with an initial value of 110 and a growth rate of 3.5%. All right. exponential functions are f of x, p, and then 1 plus or minus r, depends on if it's growth or decay, to the x. And so ours is f of x is equal to, do not just do this part. You have to write it with f of x equals, otherwise it's not a function. And it won't be right. Okay. So f of x is equal to, the initial value is 110. It is growth, so it's 1 plus 3.5%. Take 3.5 divided by 100 to change it from a percent to a decimal, 0.035 to the x. Last step, please do not leave it in this format. I will take points off. When you can math it, math it. And so 1 plus 0.035 is 1.035 to the x. Next one. Again, I will not say the words exponential. I'm not that nice. Initial value is 63, and this one's decaying, so it's 1 minus 28% divided by 100 is 0.28 to the x. Final answer is f of x is equal to 63, 0.72 to the x. Write a function again, because I'm not doing exponential. Initial value 79. It's growth, so 1 plus 119% divided by 100 is 1.19 to the x. Clean it up. Simplify. 2.19 to the x. All right. When a new charter school opened in 2010, there were 970 students enrolled. Using function notation, write a formula representing the number of students attending this charter school T years after 2010, assuming the student population. So this is our initial value for all of these. And we've got a couple of things happening here. We have linear. These two are linear because they're going up or down by a specific number of students. And so you're going to use f of x is equal to b plus or minus mx for your formula for this one, for your function. And then these two are percentages. So you're going to use exponential function, f of x is equal to p, 1 plus or minus r to the x for that one. And we'll discuss the last one. So a is linear, so f of x is 970, and then it's increasing, so plus 73 students per year. There's my answer for A. B, f of x, you always start with f of x, 970 for no other, whether it's linear or exponential, you start exactly like this. And then from here, you go to linear or exponential. This one's linear as well, but it's decreasing, so it's subtracting 36 students per year. There's your answer for B. C is decreases by 9.4%, so f of x is 970, parenthesis, 1 minus 9.4 divided by 100 is 0.094 to the x because it's per year. Clean it up, simplify, 970, 0.906 to the x. There's my answer for that one. D, f of x, 970. It is increasing by 6.1%, so 1 plus 6.1 divided by 100 is 0.061 to the x. Simplify. And there's my answer for D. E remains constant. Started off exactly the same way and then stop, because if it stays constant, there's no change. So it's just 970. Population number 17,000 organisms initially, that's your initial value, and decreases, so it's decaying because it's a percent each year. Write a function for the population of the organisms. So f of x, this is A, f of x, initial value is 17,000. It's exponential because it's a percent, so 1 decaying, 1 minus 0.08 and it's per year. Simplify that. There's your answer for A. B, predict the number of organisms after 2 years. So that's just f of 2. And we're going to substitute 2 for the x. Because this is decaying, the answer should be less than 17,000 because it's 2 years after. So you put in your calculator 17,000, parenthesis, 0.92, close parenthesis, caret 2. And you're going to get 14,388.8. Now, during our class, we all decided that organisms were like people and they are only count if they're whole. So your answer is there will be 14,388. We don't quite have a whole organism here. This is a 0.8. And you can't round up if you don't have a whole organism. There will be 14,388 organisms in 2 years. There's your answer. You saved $1,000 to invest in a savings account. Write an exponent. Write a function for the value of the investment for each situation that follows. So these are all going to be the same except for the exponents. All right. For A, f of x is equal to 1,000. And then 1.1 plus is increasing 0.04 to the x. I just need to simplify that. All right, the rest of these are going to be exactly the same setup except for the exponent. So I'm just going to set these up. All right, for B, every 2 years. Now, I told you, please make sure you have that in your wheelhouse on your note card, whatever, if you don't know it. If it's every blank years, you're going to put x divided by blank. And in this case, it's 2. Okay. Everything else will happen within a year. So you just need to know what that is. If it's every 6 months, how many times does every 6 months happen a year? Twice. So that's 2x. 2 times that a year because it happens twice a year. I shouldn't have put an x here. And then every 3 months, well, 3 months happens 4 times a year. So that's 4x. Those are your answers. Please revert back to those other ones if you want to put those on your note cards. I highly recommend that. Semi-annually is twice a year. Every 4 months is 3 times a year. Quarterly is 4 times a year. I gave you a whole list back in the day. All right. A new home is purchased for $150,000. The value of the home increases by 11%. That's exponential already. I already know that. Every 2 years, write a function for the value of the home using time in years for the input value. So f of x, initial value is 150,000 for the home. Increasing, so 1 plus 0.11 to the x divided by 2 because it's every 2 years. So every blank years is x divided by blank. So it's x divided by 2. And then your answer for this one, and we're just doing the exponential function, 3 is 1.11 to the x divided by 2. Did I do this one? Oh, I also wanted you, I had this in class as well. I want you to also find out the value of the home in 25 years. So what is the value of the home in 25 years for this one and the next one? So if you didn't do that, pause the video, go do this, and come back to see how you did. The value of the home in 25 years, because remember, X is years, is 150,000. 1, 2, 3, 1.11 to the 25 divided by 2. To put this in your calculator, if you're doing it all at once, 1, 2, 3, parenthesis, 1.11, parenthesis, caret, parenthesis, 25 divided by 2, close parenthesis, equals. If you have the TI-30XA, you have to put a multiplication sign in here. Okay, everyone else, you're using a calculator from Itha's office, so, or your own, and this should work out perfectly for you. So I need to do this one. I haven't done this one yet. 150,000, 1, 2, 3, parenthesis, 1.11, close, caret, open, 25 divided by 2, close, equals. And I got 552. Did I do this? Hold on. Let me just double check myself. I don't want to give you the wrong answer. 1, 2, 3, parenthesis. Well, it's increasing by 11%. That explains it. Caret, open, 25 divided by 2 equal. Yeah. So the value of the home in 25 years will be, pick a verb, 552,876. This you have to take to the second digit, 0.96. You have to take it to the 6. The next one, I did the same question. What will be the value in 25 years? But first, let's go ahead and do our function. And again, I won't say the words exponential. So f of x. A new home is purchased for 195,000, my initial value. And it's decreasing, so 1 minus 4%, 0.04, every 3 years. Okay, so I just need to simplify that. There's my function. Now, I want to know what will be the value of the home in 25 years. All right, so I'm just plugging in 25 for x. This should be less than 195,000 because it's decaying. All right, so I'm going to write this out, how you're going to put this in your calculator. Just like that. Except for the TI-30XAs, you have to put a multiplication sign in here. Everyone else, if you're putting it all in at once, just like that. For those of you who are doing order of operations, 0.96 caret, you're going to do this 0.96 caret. You don't need the parentheses for this one, but you do for this one. 25 divided by 3 equals, and then times 195,000. All right, but you probably already knew that. 195,000, 1, 2, 3, parenthesis, 0.96, close, caret, open, 25 divided by 3, close, equals. And I got 138,000. So the value of the home in 25 years will be, don't forget your dollar sign, 138,769. And okay, we're gonna have to round here. So this is the second 7 is my rounding digit. The 5 is my test digit. It is a 5, so we have to add 1 to my rounding digit. So 0.78. There's your answer. Let me know if you have any questions. Have a great day. Good luck.